Okay, we're going to rearrange this so that 0 is on the right side. Because we have a positive x squared already on the left, and we like to keep x squared positive. So we're going to move everything to the left. Okay, Kayla, how do I move everything to the left? What's on the right side? Okay, x plus 10, and how do I move x plus 10 to the left? Subtract. They're both positives, so we subtract x and we subtract 10. Make sure you're doing it on both sides. Subtract x, subtract 10. Those cancel. Now, careful with inequalities. Do you remember from junior high when you're graphing one-dimensional inequalities? Sometimes the sign flips. When does that happen? Divide or multiply by a negative. So be careful of that. Here we just added, so no, we subtracted. So it doesn't matter. The sign will stay the same. And I'm going to write it in standard form. My quadratic term first, then my linear term, and then my constant.
Whoa.
Whoa. Quadratic is the x squared. The linear is x to the first. Constant has no x's. Good, good, because you're already in good practice. Okay? How do we solve quadratics? Factoring would be our number one option. That's the easiest option. If we try to factor and it doesn't work, we'd go to quadratic formula or completing the square. Usually completing the square is everyone's last choice. Like, only if they were on their deathbed would they do completing the square. Okay? So quadratic formula is usually your go-to. Sometimes completing the square, though, will actually be more helpful. So let's try factoring first. If it works, we're good. If it doesn't work, then we have to go to quadratic formula. So, X box method, right? Gilberto, what goes on the top of our X? Close. Negative 10 times 2. So that would be negative 20. And Gilberto, what goes in the bottom? So we multiply to first times last, and we add to the middle. What's the middle coefficient? Negative 1. Okay, turn to your neighbor, please, and tell them two numbers that multiply to negative 20 and add to negative 1. Multiplies to negative 20, adds to negative 1. What do you have, Kevin? 4 times negative 5, will that work? Yes, good. And I saw his paper, he put X's with it too, right? Because now we're going to have to go do the box. We have to do the box if it's not 1x squared. If it's 2x squared, we have to do the box. There's a shortcut if it's just 1x squared. All right, let's see if we remember the box. Derek, do you remember how we fill in the box?
Yeah. The first term is top left corner.
Good, so 2x squared right there.
And then one of the terms you got, either 4 or negative 5, goes on the top right corner and the bottom left.
With the x, right? 4x. And then negative 5x bottom left. And what goes in the bottom right?
Last term.
Last term, negative 10. Okay? Reminder, if you need to redo your factoring test, Operation No Fail today, we'll be practicing this. Okay? So, now what do we do? In the rows and columns, right? Okay, Cindy, what is the greatest common factor in the top row? 2x. Yeah, they have that x. Okay? And the bottom row, Alicia. Negative 5, good, because they both have a negative, so we want to use the negative. Now the first column, Sadie, first column. And last column, Caitlin L. 2. Now let's make sure it all works. 2x times x, is that 2x squared? Negative 5 times x, is that negative 5x? 2x times 2, is that 4x? Negative 5 times 2, is that negative 10? Yeah, you want to make sure it works before you jump and write your factors. So, my factors are the things I have on the outside. 2x minus 5 and x plus 2. For these purposes, really we can change this to an equals 0. We're trying to find the x-intercepts, so when the height is 0, we don't want the height to be greater than or less than 0. So if you put the less than sign, it doesn't really matter. How do we solve for the x's now? The 0 property. We do a little squiggle, and yeah, each factor set equal to 0. That one set equal to 0, and x plus 2 set equal to 0. Okay, on your own, would you please solve both of them? Finding the x-intercepts. Do you need a new pen or something? Okay. Okay, the one on the right is pretty easy, right? You can just see it. The one on the right is x equals negative 2. The one on the right, you have to do a little bit of work. Some people can see it, others need to do a little work. We add 5, 2x equals 5, divide by 2, so what is x going to be? 5/2, which is the same as 2.5. So these go where on the graph? The x-axis. They're intercepts. Now if you notice, a negative 4 is written out there, which means like every 2 lines, maybe it's 3 lines. Mine's copied really bad. I think yours is a little more clear, but I think it's 2 and 3 because there's a 4 there. You need to mark negative 2 as an intercept with a nice big point, and 2.5 as an intercept with a nice big point. That's what solving does, is it gets us the x-intercepts. You can solve by factoring, you can solve by quadratic formula. Those are usually our top 2 choices. Okay, what else do we need to show the parabola? The vertex, yeah. Do you remember how to find the vertex? What? Yeah, what's that finding? Axis of symmetry. And it's actually the beginning and the end of the quadratic formula. Ugh. I kind of wrote too big, so I'm going to have to come down here. So I hope you saw, maybe you have room on the right side. I don't know. Axis of symmetry. X equals negative b all over 2a. It's interesting. The axis of symmetry's formula is related to the quadratic formula because it's on the quadratic. It's the middle of the quadratic, right? It gives us the symmetry line. So it's the beginning and the end of the quadratic formula. Okay. Tyler, what's our b to plug in here? Close. B is negative 1. So if we do negative b, it would be the positive one, because it would be negative, negative 1, which is positive 1. All over, Ryan, what is the a? 2. So we have 1 over 2 times 2 is 4. So x equals, for graphing purposes, it's easier to see the decimal than it is to do 1/4. Okay, does the vertex just have an x? Oh, what else do we need? The y. How do we find y? Plug it in, plug it in. Okay, into this. But we don't have to say less than 0. We can say equals y, because we're not looking for a height of 0 anymore. So I'm going to plug in 0.25, or you can put the fraction 1 divided by 4, as long as you use parentheses, minus 0.25 minus 10, and we'll put equals y because we're looking for the y coordinate. It's equals 0 when we're looking for the x-intercept. Okay, so type that in. It's a decimal, so I'll let you use your calculators. Make sure you square it. The first one is squared. 2 times 0.25 squared. Okay. Talia, do you have that decimal? 25, right? Yep. So that's our vertex. Our vertex is 0.25, comma, negative 10.125. If you look carefully at the y's, what are the y's counting by? Each line, each horizontal line on the y-axis is counting by 1s, because you can see there's a 1 mark there. So when we go down to negative 10, you have to count down. 1, 2, 3, 4, negative 5, 6, 7, 8, 9, negative 10. So 0.25, negative 10.125, which is just below negative 10. Now, before you draw your parabola, inequalities have another special feature. Before, in junior high, when you did one-dimensional graphing, you had open circles and closed circles. Do you remember the difference? What's the difference with inequalities? When do we have an open circle versus a closed circle? Equal to has which one? Closed. Extra line, extra fill. And not equal to is open. So similarly here, we have solid lines and we have dashed lines or curves. They don't even have to be a line, but it can be a curve. Okay, so the dashed will be less than and greater than. The solid is the equal to's. So extra line, extra fill. Okay, in our case, which one should we use? The dashed. Yep, because it's just less than. Should still look like a parabola, though, with arrows. Okay. We will be adding something onto that next time, but we're not going to do that right now. Okay. Any questions on that one? Let's look at method 2. For same example, example 6, method 2. Is everyone okay if I erase this axis of symmetry stuff? Because I wrote too big, I kind of had to go down. Okay, method 2. This will be our last one, and we don't have any homework on this tonight, but we'll pick it up next time. It says if f of x equals 2x squared. Ooh, 2x squared. What type of a graph would 2x squared look like? Tatiana? A what? Parabola, because it's quadratic. And we have a second function, g of x equals x plus 10. Maddie, what would x plus 10 look like? Is it going to be a parabola? X plus 10? No? This is x to the first power. So it's no longer quadratic, it starts with an L. Linear, it's going to be a line. So we want to solve when f of x is less than g of x. Okay? And also, we want to find where they intersect. When are they equal? We did this on 2 assignments ago. When two graphs intersect, that's the solution because they're equal at that point. Okay, so for f of x, we need to get some points so we can graph it. X and Y. Do you remember? Hopefully you do. You should be able to just look at the 2x squared and be able to tell me what the vertex is. Because if you understand what a vertex form looks like, our friends A, H, and K, what's the H? What shift? Horizontal shift, and the K is the vertical shift, and we say what phrase? Opposite, same, and that becomes your vertex. So, look by the x squared. I'll erase this here in a sec. Y equals 2x squared. What number is in parentheses with the x being squared? What number is being added or subtracted to the x in parentheses being squared? 0. It's not there. 0. What number is after the squared? 0. So 0, 0. The vertex is 0, 0. So you should be able to just, or you can do axis of symmetry and find the vertex. It just takes a little bit of work. 0, 0. I'm going to box that so I remember that's where my middle is. You should be graphing around the vertex. We want the vertex in the middle. A couple smaller than 0. A couple bigger than 0. And actually, in this case, I think even 3 is important to graph. Okay, so let's do the positives. If we plug it in, positive 1, plug it in. 2 times 1 squared. 2, because 1 squared is 1. Adam? Adam, what is 2 times 2 squared? 2 squared is 4 times 2 is 8. And lastly, 2 times 3 squared. So we do 3 squared first, which is 9 times 2 is 18. And because of symmetry, I should already know these ones. Negative 1's y value is positive 2, and negative 2's y value is positive 8. Okay, let's go plot those. And this is equal to, so it's going to be solid. Ooh, let's see here. This graph is just not printed very well for me. I think this is negative 4 out here. Negative 3, negative 2, negative 1, 1, 2, 3. Oh, this is so bad. 2, 4, 5, 10, 11, 12. Okay. So, negative 2, 8, negative 1, 2, and we have our vertex, and so we should see some symmetry happening now. And then 3, 18, that's not even on our graph. 12, 13, 14, 15, 16, 17, 18. Sure, we can put it up there. And make sure it's a curved parabola. It's solid because it's equal to. What else do we need to put on this graph? The what? The linear one, g of x. So since we have 2, it'd be good to probably label, I'm going to say that this one's f of x. G of x is linear. This is 9th grade stuff. Do you remember? I have a whole song and dance about this one too. What is y equal mx plus b? Students, are you listening to me? I say, YouTube, it's wonderful. It's my master's degree, guys. It was multimedia and music and math. Mx plus b. Like YMCA? Okay, so what is m? What does m mean? Slope. Rise over run, right? What does b mean? Y-intercept. We start with the y-intercept. Right? Have I not taught too much today? Gabby, what is the y-intercept of our g function? So the y-intercept comes after the x. It's being added or subtracted to the x. 10. Yep. So we come up here and we plot our 10. And then we use the slope to get more points. Okay, Tyler, what's our slope from the g function? So the slope is the multiplier to the x. How many x's are there? 1. So that would be 1 over 1. So we rise 1, run 1. Rise 1, run 1. And we can also go reverse to get more points. Down 1, left 1. Is that above that? Down 1. Ooh, interesting. Left 1. Down 1, left 1. And you should see it look like a line. So the question, and this is equal to, so they're both solid. The question was, when is f of x less than g of x? We're looking for an interval of time. Yeah. So it is f of x less than means it has to be lower, right? Does less than mean lower? Is lower from, well, parenthesis, negative 2 to whatever that is over there. What? What? Wherever that is. We'd have to plug it in. I don't think we have time to plug it in today. But we can see where those are equal. But that's when it's less than. When are they exactly equal? At these points, right? So this would be a solution negative 2 comma 8. And it looks like we need to find that one. We might be able to do that with our calculators really quick. Have your calculators? Okay, I'm going to go to y equals, and I'm going to type in both of these functions. Okay, so 2x squared and x plus 10. That's what I need to remember. Go to y equals 2x squared and arrow down, what was it, x plus 10? Okay, do you remember how to go to the table of values? How do we do that? Second graph. And we already know this one. They both have 8s. Let's look down here. Are they both equal again? No. But if I look at the graph, I can see. Looks like I need to change my window. I need to see a little more of the positive y. So I'm going to go to my window and I'm going to change. I don't need much y minimum, but I'm going to put this up to 20. I'm looking for where they intersect. And I can calculate that intersection. Go to second calc above the trace button. See how it says calc? Go second calc. I think it's going to be a decimal. Do one of these give us an intersection option? Number 5. And it says first curve, so I arrow over as close as possible to that intersection. Then it'll jump to the line. And make sure I'm on that intersection. I push enter 2 more times. And my intersection is a decimal. Where does it happen? 2.5 and 12, comma 12.5. 2.5, comma, 12.5. So this happens right here, 2.5, comma 12.5. So the answer to our questions of when is f of x less than g of x, it happens at an interval of time. It has to be a parenthesis because at the intersection point, they're actually equal. They're not less than or greater than. So negative 2 to 12.5. And there are 2 times when they're exactly equal. What are those 2 times when they're exactly equal? Negative 2 comma 8 and 2.5, comma, the intersections, right? Okay, so that's what we'll be working with more next time. You don't have homework on this part. Your homework, again, is the page 146, doing quadratic regression. Okay? Remember, we have operational fail today after school.